Hello everyone, today we are going to be doing some more work with parabolas, and we're going to be learning some new vocabulary about them and a new way to write the equation. So our goals for today are to identify the focus, directrix, and axis of symmetry from the equation of a parabola, graph a parabola, and we're going to work on writing equations of parabolas. So a new definition we have for a parabola is that it is the set of all points that are equidistant, which means they are the same distance away, from a point given the point, which is called the focus, and a given line, which is called the directrix. So if we look at this diagram right here, here's our parabola. And then right here is the focus, and this line down here is the directrix. So what this is showing you is that the distance from the focus and the directrix is always going to be the same. So that's where this new way of looking at parabolas comes from. So this gives us two different forms that we're going to use to write equations of parabolas. One of those forms is 4p x minus h equals y minus k squared. And the other form is 4p times y minus k equals x minus h squared. Alright, so a couple of things we need to know about these different forms. First of all, I'm going to start with the one on the right over here. When there's x squared, like we can see here, the x is being squared, that means that it is a parabola opening up or down. When the y is squared, so like this first one, that means we have a parabola opening left or right. Now from what we've done before, you already know how whether the squared term is positive or negative affects the direction it opens. If we've got x squared, and if we had, let's say I threw a negative out here, you don't need to put that in. But if there's a negative here, that makes it open down. If there's no negative, it's opening up. And then over on the other one, if the y squared is positive, like it's currently written, that would be opening to the right, which is the positive direction. If I were to put a negative in here, that's opening to the left, which is the negative direction. It's important to know the difference between those. The other thing that we want to make sure we know is that the vertex of the parabola is always h comma k. And you always switch the signs from what they are in the parentheses. Now I just said a lot of things and wrote a lot of things down, so make sure if you missed anything or don't feel like you got everything written down, you can always pause or rewind and pause or whatever you need to do. Alright. Now, the one thing we haven't talked about yet is that p out in front, which is kind of weird. We haven't used p yet. But p is really important because it tells us the distance from the vertex to the focus and directrix. And using that p-value is going to make it really easy to graph. So let's go ahead and create these graphs. So the first thing you always want to do is make sure that the squared term is by itself. So if we look at a, x squared is by itself, so that's great. Now, first thing we want to do is find the vertex. The vertex is h comma k. In this equation, there's no h or k. So that means the vertex is at 0, 0. I'm going to go ahead and put that on our graph right away. That's the vertex. Now, to find the focus and directrix, we have to first find the p-value. So I'm going to scroll back up for a second. If we look here, we've got x squared. So that's like this equation. The p is in front of the y. But what we have to notice is that it's 4p in front of the y. So since here I have a 20, that means I need to set it as 20 equals 4p. Then we want to get p by itself. So divide by 4. So that means that 5 equals p. Now that we know that 5 is p, that tells us the focus is 5 units away from the vertex. Now we need to know which direction to go. Since it's a positive x squared, that means that the parabola is opening up. So that means the focus is 5 units up from the vertex. So there's our focus, which is at 0, 5. Now the directrix is always a line, and that's p units away from the vertex in the opposite direction of the focus. So that means my directrix, I'm going to go down 5, so 1, 2, 3, 4, 5. And the directrix is a line, and it's just an imaginary line that helps us graph, so I'm going to put it in dotted. Since it's a line, we want to write the directrix as the equation of a line. This is crossing the y-axis, so that means that it is y equals -5. Now the axis of symmetry we're familiar with from things you've already learned about parabolas. That always goes through the vertex. So our axis of symmetry is going to be right here. And that is the line x equals 0. Now when we actually put the parabola on the graph, it just needs to be a sketch that opens in the right direction. So since this is the vertex, we know it's opening up. I'm going to graph in my parabola like this. Couple hints here. The parabola will always open away from the directrix, and it's always going to open in a way that it's kind of hugging where the focus is. Like if you see the focus is in the middle here, you can kind of think like the parabola is giving the focus a hug. And so that's the whole graph. Let's take a look at the second one. So first thing is we want to make sure the squared term is alone, which it is. We've got y squared. So then we want to find the vertex. There's no h or k, so again we've got 0, 0. To find my focus, I need to set 4p equal to -16. -16 is in front of the not squared term, so that's how we know to use it. So 4p equals -16. Divide by 4, and we get p equals -4. Now, since the y is squared, that means that it would be opening left or right. And since there's a negative sign in here, that means we want to open in the negative direction, which would be to the left. So to get the focus, I'm going 4 units to the left. So 1, 2, 3, 4. And that would be the point -4, 0. Now the directrix is going to be the opposite direction. So 1, 2, 3, 4. And that would be the line x equals 4. And then the axis of symmetry is going to go through the vertex, and it's always going to be the opposite direction of the directrix. They're always perpendicular to each other. So here's my axis of symmetry, and that would be the line y equals 0. So then to sketch in my graph, I start at my vertex, and I'm going to hug the focus here. A couple things to notice. The directrix and axis of symmetry will always be perpendicular, so that means one is x equals and one is y equals. They should never be the same. So if you're not sure when you're doing that second one, that can be a good way to check. If you have any questions, make sure you're jotting them down so you can ask in class tomorrow. Alright, so now we've graphed parabolas, so now we need to work on writing the equations. So I'm going to rewrite the two different equations up at the top. So as a reminder, the first one, since the y is squared, that opens to the left or right. Second one, the x is squared, so that's opening up or down. That's important to know because that's going to help us figure out which equation to use. So looking at the first one, we have a parabola that's opening down. So that tells me we're going to be using the second equation. So I'm going to rewrite that here. So 4p times y minus k equals x minus h squared. So now I'm going to start filling in the pieces that we know. So first off, we know that our vertex is right here. So there's no h or k. So those are both going to be 0. So I'm going to just have a y equals x squared. Then it's opening down, so that means it's negative. So I'm going to put a negative sign in front of my y. Now that we have that, the only thing we have left, because we've taken care of k and we've taken care of h, the only thing we have left is we need to find p. We know that p is the distance from the vertex to the directrix, and we have those two things right here. We've got the vertex and we've got the directrix. So since we have a graph, we can just count. So we go 1, 2, 3, that's the distance. So that means p is 3. And so I'm just going to multiply that 4 and 3 together. So we get negative 12y equals x squared. And there's our equation. So remember, in this equation, the y and x and the squared will always stay the same. You're just trying to fill in for those other pieces of information, the p, the k, and the h. Alright, so let's look at the second one, letter B. So this one doesn't have a graph, but looking at that, I'm like, wait, what? How do I know which direction this is going? I don't know what's going on. So the best thing you can do is start by sketching your own graph. Alright, so we have a focus at 1/2, comma 0. So I'm going to make really big spaces and call this 1 and this -1. So if the focus is at 1/2, comma 0, this is going to be where my focus is. Then the directrix is x equals -1/2. So I'm going to put that guy in right here. So now we know the vertex is always right in between the focus and directrix. So if this is positive 1/2 and this is -1/2, that means our vertex has to be at 0. And then we also know that the vertex always hugs the focus. So that means my graph has to go this way. So now this is opening to the right. That means we have to have an equation with y squared. So I'm going to put that down here. Alright, so we need to find p. P is the distance from the vertex to the focus, or the vertex to the directrix. Those are the same. And that we know is 1/2. And then for h and k, our vertex is at 0, 0, so those are both 0. So I am going to write them in even though they're zeros, because we're going to have to do another line anyway. So now I want to multiply 4 times 1/2, which is 2. And then x minus 0 is just x, and y minus 0 is just y. So I can leave that as y squared. And there is our equation. Alright, now I am just about out of time on this video, so I'm not going to go over transformations here. I want you to give them a try based on what you already know with transformations, and then in class tomorrow, your teacher will go over them. Alright, good luck!